Hello viewers, welcome back to another episode, and this episode is a bit different to other episodes because in this episode I tried to repair the VAX 4300 power supply. You can see the VAX 4300 here on the video, and there is an issue with the power supply. The machine went off after 5 minutes, 10 minutes, 40 minutes. It's a bit random when the machine turns off, so there is some kind of safety feature in the power supply which deactivates the power supply, and then there is no VAX anymore. And you will see after the intro different attempts to solve this issue, but I'm not able to solve this issue. I did not find why this is happening. I've replaced several parts on the secondary side on the power supply. I've tried different things, but I did not know or did not find what's causing the issue with the power supply, and therefore I cannot make any new VAX content because this VAX is necessary for all my VAX environment, because that machine is a DSSI hard drive with the VMS installation, and this is the only machine I have which can handle such a DSSI hard drive, so I have no other machine where I can put the DSSI hard drive into. Therefore, all my VAXs cannot run, and you won't see any new VAX content. Maybe no more, or maybe for a longer time, but until I'm not able to solve the issue with the power supply, there won't be any VAX content. We will see after the intro all my attempts, but I can tell you what at the end everything failed, maybe you want to watch it, so have fun. Maybe you have some suggestions, so you can leave comments down below, but at the moment I really don't know how to repair the power supply. Hello, yes, welcome back to another episode, and this episode is about the power supply of my VAX 4300 again. I've made 3 previous episodes about this topic some month ago, I think maybe over a year ago. After the last episode, the VAX was running again and there was no problem with the power supply. But I think there is still a problem with the power supply. So here on the left, this is the power supply of the VAX 4300. Here on the right, this is my spare power supply. But I've removed several parts from this power supply just to learn how the power supply works. But it became apparent that there is a problem with the power supply, and I think it's still a problem with the capacitors on the secondary side and several voltage rails of the power supply. And therefore I have to change several things in the power supply again. What's happened, because it's also a reason, because there was no VAX content over the last months, because I have this VAX 4300 is necessary to run all my VAX environment, because all my VAX is boot from the VAX 4300, and without any VAX 4300 I have no running VAXs. And the other thing, because there's less content at the moment, it's a bit hot in Germany over the last weeks, and my rooms have no air condition, and therefore it's not possible to run all the machines. It become quite hot in the room very fast, and therefore I cannot run all my stuff. So it's some kind of summer break at the moment. But what happened? The machine went out in the middle of operation some months ago. I've heard it, because the sound of all my running machines changed. I think something is off now, and I wasn't able to turn it on again. And after a while, some days later, I was able to start the machine again, but it went out after several minutes, and then I wasn't able to start it again. Yeah, and that's the reason why I think it's a capacitor problem. So I have here, this is the 5 volt and 3.3 volt board of the spare power supply, and there are some problems changing the capacitors. The capacitors are over here. These are the two capacitors, I think, for the 5 volt rail, and normally there are these cooling blocks mounted under the board. And the problem is, here these are, I think these are the rectifiers, and these are the rectifiers, and these are the MOSFETs. You cannot remove the screws from the for the mounting of the cooling block from the top. Yeah, I hope I can show it to you. I have a macro camera here. These are. You can see the rectifier here, and there is no hole in the board to remove the screw from the top. So I used a small plier to remove the screw like this, from the top. It was quite hard to remove it, and it's the same problem on the 12 volt and minus 12 volt board as well, as we can see later. Interestingly, these two MOSFETs over here, you can see the screws. There is a hole on the other side, so these screws, you can see it there, you can remove these screws from the top. I don't know why Digital choose that strange design of the boards, but this is the reason, because I cannot change these two capacitors over here. So they have to be removed from down below. So there are, it's a bit from there, but I will do it off camera later on. And I've also, another problem was the insulation. So there are small rings like that for the insulation of the parts, and some of them broke, so I've got new ones just to replace them. But I will do all that stuff off camera. But after I've done it, I will do some measurements with the capacitors to check the capacitors and how good or bad these capacitors are. And after that, I will do it with the 12 volt rail as well. But first, let's have a look into that power supply. And there is some words of warning, because it's in that power supply. It could be dangerous to open the power supply if you do not know what you are doing. So I think I also do not know what I'm doing. But if you know less than me, you shouldn't really open and try to repair your power supply. And this power supply wasn't in use for, I think, 7 or 8 weeks, so I don't think there is, the capacitors are not loaded anymore. And now I have to remove the cables. There are 4 of them. So this is the top. I think there's no issue with the top. This is mostly the logic for the configuration, for the check of all the voltage rails are correct, etc. So that's not necessary. Put it away. And here, this is the same board like this. This is the second 5 volt 3.3 volt board with the same problem. This is the 12 volt board, and I've replaced some capacitors in my last video. But another problem is that capacitor over here. This is a Sprague 88D, and they are not manufactured anymore. So not find a new one, but I have found a Swiss dealer. So this is a Sprague. Normally, this is Sprague from that power supply. I removed it, and I found a dealer who sold me this replacement part. So you can see there are 4 connectors, but they are bricked internally. So basically, it's only 2 connectors, and this is the replacement part is a bit higher. Also double as the original one, but I think it will fit into the power supply because there is enough space on top of the Sprague capacitor. So these are the things I will do, but first I will remove the capacitors and replace the capacitors from that board off camera, and after that we will see, I will record the next scene. Yes, I've replaced the capacitors on the 5V and 3.3V board. You can see it here. Let's have a look on the macro. There are new capacitors, and the change I've also did is on the back. On the back I've changed the screws, so I cut a slot into the screws on the other side, so now I can use a screwdriver to remove or put the screws back into the cooling block, so it's much easier to remove the cooling block again. But it was a total nightmare to replace the capacitors because there were the rectifier nearby the place where the capacitors are soldered in. So that's the thing I want to do again, and I hope I did not damage the rectifier on the back. But another thing here, this is the capacitor. I've built out the capacitor, and you can see it's I've destroyed one, but one is I was able to remove without destroying it. You can see it leaked, and I've got a new measuring equipment. It's an LCR meter from Matrix, MCR 5200. And with that tool I'm able to measure the capacitors, and not the capacity, also the resistance of the capacitor. LCR meter is a quite interesting tool. It measures, I think it's more or less an instrument to measure the impedance, and you can also see the angle phi with it, and also can calculate everything. I think with the resistance and the angle you can calculate everything, but here on top you can see there is it shows the capacity and the serial resistance directly, so I don't have to calculate it. And this is frequency, so this tool loads and unloads the capacitor with a specific frequency and a specific voltage. So it's quite complex. On the channel EEV blog is a video which explains how this measure equipment works in detail. We'll link that down below. But for my usage, it's I normally only need the capacity and the serial resistance. And let's check this capacitor here. This is the capacitor I've replaced it with, and let's measure it. And you can see it's 309 microfarad. This is normal, because when I go to a lower frequency, so I will decrease it, then the capacity is now with 100 Hertz. The capacity is nearly 330 microfarads, so it's okay, and the serial resistance is 0.2 ohm. This is also okay, but because this is a switching power supply, I think 100 Hertz is too low to emulate what the capacitor really is doing in the power supply. So I think a kilohertz, 1 kilohertz is okay, but it's totally normal that the capacity is lower with a higher frequency, and also the impedance, the resistance, the serial, is quite low. But let's have a look what is the value for the capacitor I've took out of the power supply, and we can see it's 260 nanofarad, so it's way too low. It should be 330, about 300 microfarad. So I think this capacitor is broken, and completely broken, and also the resistance is 2.5 ohm. So yeah, I think this is the reason why the power supply did not work anymore. So this is from the spare power supply, and I think the spare power supply was the original power supply from the VAX 4300, and the power supply which was in the VAX server 4300 before, I've used in the VAX server 4300 the last year, was a power supply from a storage expansion. And that could explain that the capacitors in the 5-volt rail are broken in the original VAX server 4300 power supply, because there is much more load on the 5-volt rail in a VAX server than in a storage expansion. A storage expansion is mostly only 12-volt needed for the hard drives, and not much 5-volt. So therefore, I think this was the point, and the spare power supply, other one is not spare power, so on the right, the spare power supply did not start anymore, and I think you need 5-volt and 3.0 to start the internal logic of the power supply, and therefore there was, input 5 was completely dead, but I will put now this 5-volt board into the other power supply. But here are two more capacitors. So this is the Sprague 88D from the spare power supply. And let's measure this capacitor with the LCR meter, and we can see about 6 millifarad. So it's okay, and an internal resistance of 0.01 ohm, and it's normal because this is the capacity is quite high, and it's not possible, I think, to load the whole capacitor in that time. We can see the resistance, the internal resistance is okay, so the ESR is not a big issue with the Sprague. So let's use the replacement, the newer one. And it's not bigger, it's also about 6 millifarad. Also when I decrease the, so it's also 6, and we can go also higher to 1 kilohertz, 1 kilohertz, 1 kilohertz, and we can see 5.5, so it's maybe a little bit lower than the Sprague. So I think this Sprague was not broken in the spare power supply, so I can still use the Sprague capacitor, and maybe it's not necessary to replace the Sprague, but I hope I can measure the Sprague on that 12-volt board without desolder it, but because maybe sometimes it's possible to use an LCR meter and you can measure some values in the on the board without desoldering the component. So first let's here go to put this one to the left. First put the capacitors away. So let's change the 5-volt board. And have a look where there are, that's too big, another screwdriver. Which screws I have to loosen, because some screws are only for the cooling block, some screws are for the whole module. And I hope I did not blow up the whole machine with my experiment. Okay, I think it's everything is. Because when the Sprague is still okay on the 12-volt board, I do not have to remove the cooling block, because I can replace these 3 capacitors like the last time without removing the cooling block. There's something, yes. So this is the 5-volt module. It's the same like this one. There's also some isolation between the lower cooling block and the cooling blocks on the back. I forgot to remove the screws here. So and one advantage is when this board is working, I have the second one, this one, this is working as well, and maybe I can build a second working power supply with the spare power supply later. So then I have two power supplies, and I hope that when I'll get a second VAX 4300 someday, and then this VAX 4300 does not need a working power supply because I have a second working power supply. I would have a second power supply then. So this is also an advantage of all of my building procedures, but on the 12-volt board on this spare power supply, I broke one of the rectifiers. So I need to buy it again. And they are not, the original rectifiers are not produced anymore, but I found a new one which should be compatible from its data sheet. Oh, I broke the screw. That's not good. Something I have to solve as well, or I will use only 3 screws now. But this is also not an issue. I think I broke one of the screws in the other power supply as well. Yeah, that's not a problem, I think. Yeah. Oh, the screw is loose. So this is a 12-volt board, and last time I did some changes on that board. So what I've done is I've bridged this MOSFET over here because there was an issue with the minus 12 volt line. This MOSFET is for the controlling the minus 12 volt, and this capacitor here on the right, this is the capacitor for the minus 12 volt, and my guess is that this capacitor is broken already because yeah, it's too much stress for that capacitor when the MOSFET is bridged. So I will measure this MOSFET over here, this capacitor over here, and I will measure also this Pragu. So I think you can see it here is the same problem like on the 5-volt board. Here is the cooling block, and there are the screws, and there's no possibility to access it from the top. So I have to use the same way to remove it like on the 5-volt board. But I hope I can measure the capacitors without removing them. So let's try it out. That's big, way too big. 617 micro, that's way too big. The other one, that one here. So there will be capacitive elements on the board, and it's way too low. That's okay. Yeah. So I think I have to remove this Pragu I have to remove the board, and then replace the sprague as well. And maybe there the problem is over here, and here's another capacitor, but I don't know what is the problem with that capacitor over here, so I think I will desolder them and then measure them without the board. Yeah, then I will do off camera, remove the cooling block. I think it will be quite hard to remove it because these screws here are not easy to reach with the plier. So, yeah, I will have to check how I will do it. So I've replaced a lot of parts of the 12-volt board. You can see here there is the new capacitor, the sprague capacitor. I've replaced it. I've replaced also the 330 microfarad capacitors and also 100 microfarad capacitor. But I've measured all these 5 capacitors with the LCR meter, and I think they were all okay. So maybe the issue wasn't the 12-volt board, maybe the old 5-volt board has gone. I didn't measure it because I have to remove the cooling block from the 5-volt board, from the other 5-volt board as well, and this is too much work, but maybe this is I hope a future-proof solution. But all in all, I have to I have to find a new power supply solution, because these power supplies are really bad to replace parts from the power supply, so maybe I have to find a new solution which provides 3.35 12 and minus 12 volt for the VAX 4300 in the future. But from now I will build it all together, and after that I hope that everything will work. So we'll put the power supply back into the VAX. Let's put this board away. So put the power supply back into the VAX, and I hope that do not burn down the whole building after that. But this is something that can happen every time when you play around with power supplies, especially with quite strong power supplies like this one here. So all screws are tight, and now I need the upper part. Maybe also something on that board is broken. I really don't know. Maybe something from the logic, but I do not hope that it is the logic of the power supply. So let's connect everything back together. Don't know if this is can view it on the cameras. Okay, now it's done, and I hope that this power supply will work again. So let's go to the VAX server 4300, build it in, and try it out. Now it's installed, and here's a fire extinguisher for case of an emergency, and just turn it on. No. But it says error with the cooling system. Okay. Cooling error. Interesting. That means there is now a problem with the whole 12-volt rail. That's bad. Okay. Yeah, then I have to do another try. Yeah, I found the issue quite fast, because it's my own stupidity. I forgot to put in the screws here, and then the connector did not connect with the big plane of the VAX. Yeah, and so I have to open the whole thing. That's the reason why it won't start. I went into that room here and saw the screws on the desk and said, oh, it should be 4, but there were 8 screws, and yeah, it was quite obvious that I forget to connect them. And that's the reason why it won't work. So there's no 12-volt connection on the backplane, and then there is no 12-volt connection. There is no fan, and then there is the fan error. Yeah. I hope that this is the only problem. But I have to, without the screws, it won't work. Yeah, I will finish that now, and then I will put the power supply back into the VAX, and then we will see if it will start then. Now I'm back for another try. So here's the power supply again, and now the connection is built in. Oh, tightened with screws. Let's try it again. So, I'll try. The machine is on, but there is no voltage, okay. Only the 12-volt rail is there. So I think there is also a problem with the 5-volt board. Then I will have 2 possibilities. There's no 5-volt at the moment. But then I think the logic won't work. Or 5-volt is not provided correctly. It's only the... But 12-volt is working with the... Okay. Yeah. Then I have to build in the other 12-volt board again. But I don't know how good the capacitors are on that board. Okay, one last try. I've placed the 5-volt board again. So this is the 5-volt board where I replaced the capacitors, but I put the old 5-volt board back into the power supply and try it out in that configuration. That configuration starts. So this 5-volt board is not working, but there's one question now. How long will it last? Because if the problem was caused by the 5-volt board because capacitors were too bad, then the machine won't work for a longer time. So therefore I will wait now half an hour and check if the machine will be able to run for at least 30 minutes. And then I know the problem is gone. Then maybe the problem was caused by one of the 12-volt capacitors, maybe one of the bigger ones. If that's not the case, I have to go deeper into the secrets of that power supply. Now it's half an hour later and the machine is still running without any problems. I did not boot at the moment, but I just keep it running and on. And in the meantime, I've started the whole cluster. So now we'll try. Yeah, you got it. It doesn't work. Several minutes after booting into OpenVMS, the machine went out again. Though I think the problem is not located on the 12-volt board, it's located on the 5-volt board. When I just let her run the machine for 45 minutes, there wasn't any operating system booted, so it was just doing nothing in the machine. And after that, when the operating system is booted, the machine will do several things. I do know how big is the load on the 5-volt rail per running operating system. I do not think machines from the late 80s or early 90s have something like power save features in the CPU or something like that, but maybe there is a big difference in the load, which is so big that the 5-volt board cannot handle this load. Therefore, I will now remove the other 5-volt board, for the 5-volt board that was original in this power supply, which is now in the power supply again, and check the capacitors on the secondary side on that 5-volt board as well. Yeah, I think that was the issue. The issue were the capacitors on the 5-volt board. The other 5-volt board does not work, but this 5-volt board works in general. But here are the capacitors, and let's have a look on the LCR meter. I've done it before, so I know the values are very bad. You can see now with 1 kilohertz we have zero resistance of 10 kilo ohm and just 15 nanofarad. So let's change the frequency a bit. If we go to 300 hertz, it's 20 ohm resistance and 55 nanofarad. So it's way too low. So the capacitors are not able to 10 ohms resistance and 15 nanofarads with 1 kilohertz, which is I think a common load for a switching power supply. So the capacitors are broken on that board as well, and that's the reason why the machine went out. It's a bit hard to measure it. 16 nanofarad. So nothing. The other one has the same values. These capacitors are broken, and that's the reason why the machine won't work. So I will solder in new capacitors into the machine and then put everything back together, and then I will do another test with that power supply. But I will do all the soldering and all that stuff off camera, so next thing you will see the power supply back in the machine. So now I've put the power supply back into the VAX again. So now let's try if it will turn on. But first I need the fire extinguisher for the case of a fire, and then let's try it out. Ooh, yeah, it starts. So now there's only one question: how long will it run? So now we'll start everything, the cluster and all the stuff here in the room. Today is fortunately a colder day, so I can run all my stuff without any problems with the heat. Then I will do a long-term test if the machine will be on for several hours. And when that will work, we will see again, and you will see the result in the next scene. Yes, and the machine went out again, so it turns off. So this wasn't the issue as well. I've tried out other things. I tried to change the board with the logic where all the safety features are implemented, and this won't work as well. So therefore I've tried out, maybe it's a cooling problem, because after I opened the power supply some parts are a bit hot, I've soldered in the MOSFET. I've soldered out in the previous power supply episode but then there wasn't any, then the voltage okay. light or voltage or key indicator does not turn on, so therefore the -12 volt rail is broken with the MOSFET, so I remove the MOSFET again, and then there's a switch inside the power supply to set the fan speed to the maximum, and I flip that switch, and then the fan is run with the full power. But after a while the machine turns off again, so it's not a temperature issue. I think there is maybe two possibilities. There is something broken in the power supply, which causes that the safety feature activates, or the logic of the safety features are broken, but I'm not able to find the one issue or the other issue, and therefore I cannot use the power supply. And as I said in the beginning of the video, without that power supply I cannot run any VAX here at my place, and therefore there won't be any VAX content for a longer time or forever, I don't know. But I hope you found this, I don't know, quite long electronic episode interesting. If you are still there and watching it here at the end, I think maybe 45-50 minutes, I don't know. And maybe we will see in the next episode, which won't be a VAX episode, because there won't be any VAXs.